All right, hi everybody. So thank you for joining this live stream. So we have three interesting stories to cover. So we're going to be covering Centaur 29P, the Black Moon, on tonight and into tomorrow morning, and then SpaceX's 10th Starship flight test. So I've linked the articles I'm using for this video in the description box down below, so you can follow along with those. So for Centaur 29P, first of all, what is a centaur? So it's called a centaur because this object exhibits traits of both asteroids and comets, so it's a weird, like, in-between object. So it's called a centaur because it's like centaurs, which were half human and half horse from mythology. So that's why it is called that. So this is just past Jupiter, and this has been happening for a long time. A few years ago, it set records for outbursts. So in September 2021, it exploded like 4 times in a few days. So it's an incredibly active comet. So well, Centaur. You'll see, I've seen another video, at least call it a comet. I think I haven't seen it called an asteroid. It's hard because not many people are familiar with the term centaur. I actually did not know what this was before doing the research for the video I'm working on, which will be out this weekend, should be out this weekend, at least I'm doing a video on the 10th Starship flight as well, which will be out hopefully Saturday, definitely by Sunday, since the flight is supposed to be Sunday evening, and I'll have more updates about, if it gets delayed or whatever as well. And then after the launch, I will be doing a breakdown. So let's talk about this. So everything we know about it, why we think it acts out so violently, and some recent discoveries of the James Webb Space Telescope that are really flipping a lot of those assumptions on their head. So in 1927, this Centaur 29P, or what would become Centaur 29P, it was originally classified as short period comet. It was discovered by two astronomers at Hamburg Observatory, Arnold Schwassmann and Arno Arthur Wachmann. I'm probably pronouncing this not right, but anyway. So they discovered Centaur 29P while comparing a series of photographs of the night sky. Originally classified, as I said, as a short period comet, it was later reclassified as a centaur, which is the name given to a group of small solar system bodies orbiting the sun between Jupiter and Neptune. So again, they're called this because they exhibit characteristics of both comets and asteroids, much like mythical centaurs were half human, half horse. It's thought that centaurs originated in the Kuiper belt, but they eventually moved inward due to subtle gravitational influences of the gas giant over the past few million years. So they generally have elliptical orbits, but they're also unstable. So they generally have elliptical and unstable orbits. Most will eventually be flying into the inner solar system as comets to possibly join the Jupiter family comets, or be catapulted out of the solar system entirely. So because of this, centaurs represent kind of a short-term, short-lived transitional state in a small body journey from the Kuiper belt to the Jupiter family comet. So speaking of if it could be launched into the inner solar system, when do we think that would happen? We think it could happen as early as 2038. it might not happen in 2038. It could potentially happen later, but as early as 2038, when a conjunction with Jupiter will change the path of its orbit. However, Centaur 2019 is different from most Centaurs in two big ways, which will be relevant later. So, let's look at that. Okay, so firstly, its orbit isn't elliptical. It traces almost a perfect circle around the sun. And secondly, it's very big. It measures 60 kilometers in diameter, making it wider than 96% of all centaurs, and is one of the largest known cometary bodies. It's also undergoing extremely violent eruptions. So I cover all kinds of these fascinating astronomical events on this channel. I do next videos and more, so if you're interested, definitely consider subscribing so that you never miss a video or live stream. So let's discuss this. So it explodes a lot. So it's the second most active body in the solar system after Io, exploding an average of 30 times per year. And 40% of these strong outbursts don't happen in any kind of predictable fashion. These explosions are erratic, sudden, and very intense. Following an outburst, Comet reaches peak brightness in about 2 to 3 hours. In 2024, for instance, it made headlines when it erupted 4 times in 48 hours. So it's 2024, I think it said like 2021 already. So it's 2024, so it's appearing almost 300 times brighter than normal. So 2 years earlier, it shot more than 1,000,000 tons of debris into space faster than the speed of sound. So that's notable. So the main outburst then triggered 2 smaller outbursts 5 and 7 days later, respectively. And this seems to be a common occurrence for this comet. And even though those sound incredibly violent and powerful, things do get even bigger. So in September of 2021, Centaur 2019 underwent the largest outburst in 40 years when it blew its top 5 times in a row. Despite this massive blast, so let's talk about the role of amateur astronomers in this study. So despite this massive blast, it wasn't actually scientists who first noticed, it was amateur astronomers. So this is one of the curiosities of Centaur 2019's history. Most of its eruptions are first observed by hobbyist stargazers because it's much easier to pull out your backyard telescope than get approval to point a multi-million-dollar publicly funded instrument on your special interest or randomly exploding Centaur. So when scientists heard what had happened, first they managed to secure precious Hubble time to take a closer look. However, other things happened. So as luck would have it, the day before the scheduled observation of Centaur 2019, Hubble experienced a technical glitch and couldn't be used. So talking about these outbursts, what causes these outbursts? So what do we know about Centaur 2019's properties that could explain them? So if you suspect volcanoes, you're kind of right, but not the hot fiery kind. They're ice volcanoes. So let's talk about cryovolcanism. So Centaur 2019 is what is called a cryovolcanic comet. So these are generally covered in an icy shell with ice, dust, and gas inside, mainly carbon dioxide carbon monoxide and nitrogen gases in a frozen icy state. So over time, solar radiation causes the crust to weaken and the icy interior to sublimate from solid to gas. So this forces internal pressure to rise. Eventually, it gets too much and the outer shell cracks, unleashing a visceral eruption of cryomagma from the inside of the comet, a mix of frozen water, ammonia, salt, and volatile gases like methane and nitrogen gas. So let's look at this. So it's an ice volcano. So Centaur 29P's nucleus has a high state velocity, and most of these aren't ejected fast enough to break from its gravity. The result is that most falls back onto the Centaur surface to reform its crust. This may then trigger the knock-on outburst 5 or so days later, as we saw in the 2021 outburst. So around the comet nucleus, the ejected dust and ice particles form a hazy reflective cloud that lingers for days, up to a couple weeks, making the comet look brighter, sometimes by several orders of magnitude. Some cryovolcanic comets like 12P, also known as the Devil Comet, the horn-like plumes that formed during its outburst. That was the one that was seen during the April 2024, or no, that Palms Brook, actually. No, so that was earlier, so around that time. So 12P is known as the Devil Comet, so, and that's a cryovolcanic comet. So as you might expect, the closer to the sun they get, the more active and volatile they become. I mean, that's something we see to a less extent just with normal comets, right? Because when, so all this gas and dust can rot around the comet, and then once it gets close to the sun, the ice melts, that's release, all of that. So that's just normal comet behavior, but it's obviously more extreme with these cryovolcanic comets. So Centaur 29P, though, is on a circular, not elliptical orbit. So it's always roughly the same distance from the sun. So you'd expect a pretty even absorption of solar radiation and regular predictable activity. So that's what has a lot of astronomers and scientists confused with like these outbursts and the fact that we can't really predict them. Like 40% of the outbursts are not predictable. So that's what has a lot of astronomers and scientists confused. So let's talk about predicting eruptions. So scientists have been trying to work out if there's a method to the madness of the Centaur's explosions for years. Some have speculated that the eruptions may be related to its slow rotation period of 57 days. More specifically, they observed that major outbursts were more likely to happen every 52 to 60 days. However, smaller outburst events also occurred every 30 and every 90 days, with enough regularity to make scientists think there might be some kind of seasonal cycle governing this comet. So While Centaur 29P's eruptions seem to happen quasi-periodically, they are unpredictable in terms of intensity or precise time. So astronomers did try to anticipate these though. So for instance, in April of 2023, scientists noted that the light surrounding the comet's nucleus had become fainter than ever, suggesting a slow rate of outburst. So the predicted pressure was building up inside the nucleus at a faster and faster rate, making an eruption highly likely. And just like that, Centaur 29P gave off a mini outburst later that very same day. So it was the first successful prediction of an eruption on this weird and volatile little world. So for the first time, we weren't just reacting to randomness, we got kind of on the inside track. So we are getting to a point where we can better predict it. Not entirely, there again are still some amount of the eruptions outbursts that we can't predict, but at least we can predict some of them. So that's good. So, and thanks to the James Webb Space Telescope, we were about to have another breakthrough. So let's talk about the depth of gas in this comet. So until recently, we had never detected carbon dioxide on Centaur 29P. Carbon monoxide was always seen as the driver of these eruptions, mainly because it is consistently found in high amounts around the comet. However, in 2024, data from the James Webb Space Telescope showed us that that was only half the answer. Data from previous radio wavelength observations of Centaur 29P showed a carbon monoxide gas jet pointed towards Earth. However, Webb's near-infrared spectrograph brought the jet's composition into greater focus, revealing not one but two jets of carbon monoxide, one pointing to Earth and one pointing towards the north. And that wasn't all. The JWST also revealed two jets of carbon dioxide emanating from the north and south direction, the first definitive detection of the gas on the comet. So the difference in abundance of carbon monoxide and dioxide suggests that Centaur 29P might not actually be just one object, but it might be several objects that have become stuck together. So as for the cause of the outgassing itself, scientists aren't exactly sure. So one interesting theory, though, is that has been put forth to explain the high carbon monoxide levels associated with Centaur 29P has to do with amorphous versus crystalline ice. So carbon monoxide is extremely volatile, and pure carbon monoxide ice can sublimate at temperatures as low as 25 Kelvin. If it were stored near the Centaur surface, it would have all escaped a long time ago. So, of course, then it must instead be trapped or preserved deep below the surface somehow. So, one possible solution to this problem is amorphous water ice. So, almost all of the ice we know on Earth is in crystalline form. Crystalline ice is characterized by a structured, ordered arrangement of molecules. Amorphous ice, on the other hand, is not tightly packed. This makes it less dense than crystalline ice. It also means it can hold gases within its structure. At temperatures above 77 Kelvin, amorphous ice turns spontaneously into crystalline ice. The higher the temperature after this point, after the 77 Kelvin, the faster this conversion occurs. So in this process, trapped gases are released. So in theory, if Centaur 29P still has amorphous ice in its core, along with trapped carbon monoxide, and that ice is undergoing conversion to crystalline form, then that could be where the high levels of carbon monoxide are coming from. So how plausible is this? So let's break this down. So Centaur 29P started in the Kuiper belt with temperatures ranging from 30 to 40 Kelvin. At this temperature, all the ice obviously would be amorphous since it's going moon starts crystallizing above 77 Kelvin. As it traveled inward over 10 million years to its current location at 6 AU from the Sun, however, temperatures rose to 115 Kelvin, and its amorphous ice started converting to crystalline ice. However, how long it will take for all the amorphous ice to turn crystalline? So, I mentioned earlier that Centaur's 29P size is going to play a role. So this is that part. So first researchers took 4 known small Centaurs. So they're all measured between 1 and 6 kilometers across and were in a similar orbital path. So a similar orbital position to 29P. So they calculated that it would take those Centaurs between 0.1 to 6 million years to convert the amorphous ice, which first of all, that's quite a range. Make sure that's in a typo, but yeah, that's quite the range. So, in the crystalline ice. So in other words, by the time they arrive in this position, they're already fully crystalline inside. So all trapped gases are released, no instability. So that's predictable behavior. However, a Centaur the size of 29P would take between 60 and 100 million years to convert all its amorphous ice. If these calculations are correct, the Centaur may have only converted between 50 and 65% of its amorphous ice. And this also has huge implications for its behavior. So, converting lower density amorphous ice into higher density crystalline ice would shrink the overall volume of the nucleus. This could induce structural failures in the Centaur's surface and interior. So some believe the subsequent cave-ins, landslides, and sinkhole creation events could be the driving force behind the Centaur's erratic outbursts. However, regardless of this explanation, there is another problem. Centaur 29P doesn't slowly release gas. It erupts explosively, sometimes multiple times per year. So how the pressure can build up fast enough to elicit several explosions back to back in quick succession is still not fully understood. So now let's talk about the future. So why Centaur 29P undergoes these bursts of brightness and how its outgassing works remains two of the biggest areas of investigation relating to this highly active cosmic body. So it challenges a lot of our assumptions about how fiery icy bodies can be in our solar system, and we still don't know as much about them as we would like. However, as I detailed some throughout this video, we have made progress. We have established general properties. We can predict some of the eruptions, the outbursts, like 40%, right? So, or 60%, I think, something like that. I think it's 40% can't be explained or predicted anyway. So, and thanks to the James Webb Space Telescope, we're only going to keep learning more. So that was about Centaur 29P, and it's definitely a very unique object to keep studying. So now let's talk about the black moon. So this is a very interesting event. So first of all, what is a black moon? So a black moon is not an official astronomical term, first of all. So it's more rooted in folklore. So that's where that comes from. So it's called a black moon because it's a type of new moon. So let's look at that. So this article, and I've linked this in the description, is from timeanddate.com about the black moon. So I would definitely suggest checking that out. So it's a special kind of moon phase be able to see it, except when you can. So you won't be able to see this one. I'll get into it. There are times when you can see them. It has to do with new moons and solar eclipses and all that. So that's when you can see them. But let's talk about this. So the next black moon is on August 23rd, 2025 in most of the world. It's on August 22nd in Western time zone and falls under the seasonal definition. So there's seasonal black moons, and there's also monthly black moons. So what is a black moon? So black moons are typically the opposite of blue moons. So there are two main definitions, as I said, a monthly and a seasonal black moon. So a monthly black moon, this is defined as the second new moon in a single calendar month with two new moons. This is the most common black moon and occurs about once every 29 months. And then the other type of black moon is a seasonal black moon. This is defined as the third new moon in a season of 4 new moons. So these black moons are a little rarer and occur about once every 33 months. Earth seasons are about 3 months and typically have 2 new moons, but sometimes a season has 4 new moons, and the third new moon is called a black moon. It is thought that the third new moon, that it is the third new moon because this definition is the exact counterpart to the original definition of a blue moon. So the date, let's talk about this. So the exact date depends on the time zone. So a black moon, as I said, is not an official astronomical term, but it refers to new moon occurrence, rare new moon occurrences in our calendar. So because a new moon is defined as a moment in time when the sun, moon, and earth are aligned, black moons can happen in different months depending on the time zone. So unfortunately, like any other new moon, it will be invisible in the sky. So this is because the moon is between the earth and the sun in its orbit in its moon phase. Its unilluminated side, so its invisible side, faces Earth, and only the far side is illuminated. So we can't see it, right? So another reason that the new moon can't be seen is that it occurs at the place in the moon's orbit when it passes through the same part in the sky as the sun and is lost in the glare of the sunlight. So there are some other definitions of black moon. So it's a rare occurrence where there's either no new moon or no full moon in February, for instance. So that's another one. That's sometimes referred to as a black moon. Both can only happen in February, as this is the only calendar month shorter than a lunar month. And their occurrence depends on time zone. Once every 19 years, there is also no new moon in February. When this occurs, both January and March have 2 new moons instead of just one. In New York, for instance, the next time this happens will be in 2033, while the last time was in 2014. Similarly, once every 19 years, February does not have a full moon. Instead, there are 2 full moons in January and March, also known as a double blue moon. Again, taking New York as an example, the next black moon by this definition will occur in 2037, while the last one was in 2019. So when can you see a black moon? So again, as I said, the date that this will actually occur is August 22nd into the 23rd, at least for the United States. So, but you can't actually see this one. So, but there are a few times a year when one can see the new moon in a dark sky, and that's during a solar eclipse. So 2 to 5 times per year around the globe, right? The new moon comes between the Earth and the Sun, and the new moon, or at least a part of it, is then visible as a silhouette in front of the Sun. For instance, this happened August 21st, 2017, during the solar eclipse, when a seasonal black moon covered the Sun for a total solar eclipse known as the Great American Eclipse. So So that was all about the black moon. Again, we can't really see it, but there are sometimes you can, and it's just a cool event to know about. So that was why I wanted to talk about it. So now let's talk about SpaceX's 10th Starship flight test. So this is one that there's been a lot of buildup. There's been a lot of different developments. SpaceX has made a lot of changes. So, for instance, they changed stuff going on with the grid things, for instance, and there are different changes with the flight itself. So, but most of really the objectives are going to be the same because they haven't accomplished a lot of them. They will not be recovering the booster though. So that's something to know if you're going to watch it, try to see them catch the booster because that's always a huge draw. Obviously, I mean it's an amazing thing to see. I've never seen it in person. I wanted to be the one time I was able to go down there was the sixth flight test when Trump was viewing it. So that was a whole thing, but unfortunately they didn't try to recover the booster there. Still an amazing experience. So, there's still that, but if you're going down there specifically to see them test the booster, that's not going to happen. And so just keep that in mind. So, and also definitely, pay attention to that date. Have flexibility also because, it could get scrubbed, might not happen on that day, might not happen at the time they're saying it's going to happen. The launch window opens at 6:30 p.m. Central Standard Time, but that doesn't mean they'll launch right then. Typically, they launch about 25 to 30 minutes after, although sometimes it's later. But the launch window is 1 hour. So, what are they going to try to accomplish on this flight? So, all of the things that they didn't accomplish on the previous flights, they're going to do a directional flip. They're going to try to deploy Starlink simulators. They're going to try to relight a Raptor engine in space, and they're going to test catch pins on Starship because they're going to eventually try to catch that as well. Once they get, make sure they can catch the booster, and then they're going to, once they also test other things, make sure they can get Starship, the second stage up to space and then back, and they're going to start trying to catch it. Hopefully that will happen sometime next year at least. I mean, SpaceX and Elon Musk also claim they're going to try to go to Mars next year. Unmanned missions, but still, I'm going to do another video on that. I don't see that happening. So, but yeah, so it will be a very interesting flight. So let's go a little more into detail on that. And that's the last story. And so let's see. So scheduled for August 24th. And they also released a report on Flight 9 and what went wrong. The interesting thing about the 6:30 p.m. Central Time opening of the launch window is that it will still be light out. So that'll be interesting. so that they can get some daytime flight data. And then also, from a photography viewer perspective, that's also better for viewers and for photographs and stuff like that. So SpaceX arrived after completing the investigations into the loss of Starship on its ninth flight test and the Ship 36 static fire anomaly. Hardware and operational changes have been made to increase their reliability. So let's talk about the hardware and operational changes. So the upcoming Flight 10 will continue to expand the operational envelope on the Super Heavy booster with multiple landing burn tests planned. It's also going to target similar objectives as previous missions, including Starship's first payload deployment and multiple re-entry experiments geared towards returning the upper stage to the launch site for catch in the future, hopefully in the near future. So hopefully they're able to get the payload door open and we're able to finally see some Starlink simulators deployed. So it's really awesome that SpaceX is so open about their development process and keeping people up to date. Speaking of, if you want to be up to date about all these major astronomy and spaceflight events, why not subscribe so that you never miss another video or live stream. So the booster on this flight test is attempting several flight experiments to gather real-world performance data on future flight profiles and astronomical scenarios. Speaking of, I haven't heard that it's a reused booster, so I believe it's a new one. So the Super Heavy booster will attempt these experiments while on a trajectory to an offshore landing point in the Gulf of America or the Gulf of Mexico, but recently renamed the Gulf of Mexico. So, but obviously when they say offshore landing, it's just, it's gonna, splash down in the ocean. That's what that means. So it's not going to return this time to the launch site for catch. So following stage separation, the booster will flip in a controlled direction before initiating its boost fast burn. So this maneuver is going to, this maneuver was demonstrated for the first time on Flight 9 and requires less propellant to be held in reserve, which enables the use of more propellant during ascent to enable additional payload mass to orbit. So the primary test objectives for the booster will be focused on its landing burn and will use unique engine configuration. One of the three center engines, for instance, will be used for the final phase of landing and will be intentionally disabled to gather data on the ability for a backup engine from the middle wing to complete a landing burn. The booster is then going to transition to only two center engines for the ending and the landing burn, entering a full hover while still above the ocean surface, followed by a shutdown and drop into the Gulf of America. The Starship upper stage, so let's talk about that. So let's talk about the second stage. So it will again target multiple in-space objectives, including the deployment of 8 Starlink simulators similar in size to next-generation Starlink satellites. The Starlink simulators will be on the same suborbital trajectory as Starship and are expected to demise or to burn up upon re-entry. A relight of the single Raptor engine in space is also planned. And the flight test includes several experiments focused on enabling Starship's upper stage to return to the launch site. For instance, a significant number of tiles have been removed from Starship to stress test vulnerable areas across the vehicle during re-entry. Multiple metallic tile options, including one with active cooling, will test alternative materials for protecting Starship during re-entry. On the sides of the vehicle, functional catch fittings are installed and will test the fittings' material and structural performance. along with the section of the tidal line receiving a smooth and tapered edge to address hotspots observed during the entry on Starship's sixth flight test. Starship's reentry profile is designed to intentionally stress the structural limits of the upper stage's rear flap while at the point of maximum entry dynamic pressure. So that's what's happening for Flight 10. But let's talk about Flight 9, because SpaceX just revealed more details about what happened during that flight, which wasn't quite fully successful. And yes, it was a completely different problem than the V2 ships had on Flight 7 and 8. So Flight 9's new issue, which they had hopefully fixed. So let's talk about that. So if you remember, all the way back to May 22nd of this year, Starship's ninth flight test successfully lifted off at 6:36 p.m. Central Time from Stardate, Texas. The test began with the first Super Heavy booster to be flown, starting up successfully and completing a full duration ascent burn with all 33 of its Raptor engines before separating from Starship's upper stage in a hot staging maneuver. During separation, Super Heavy performed the first ever deterministic split, followed by its boost-back burn. So, and remember, this was a huge milestone I feel didn't get enough recognition. It's the first booster to be reflown, Booster 14. After completing the boost-back burn, Super Heavy flew a significantly higher angle of attack than previous flights during its ascent back to Earth, reaching a peak angle of approximately 17 degrees. This trajectory was a flight experiment to gather data on the limits of the booster's performance. Once it reached its point of splashdown area, the booster relit 12 of the 13 planned engines for its landing burn. Shortly after the burn started, an energetic event was observed near the aft end of the vehicle, followed by a loss of telemetry. Final data was received from the booster approximately 382 seconds into flight, so 6 minutes and 22 seconds, and at approximately 1 kilometer altitude over the designed clear zone. The most probable cause for the failure at the landing burn was higher than predicted forces on the booster structure, specifically on the fuel transfer tube due to the increased angle of attack experiment. So they were never planning on recovering the booster anyway, they were stressed. So post-flight, the analysis showed that the vehicle's loads exceeded the capabilities of the transfer tube, which is believed to have experienced a structural failure, which resulted in a mixing of methane and liquid oxygen and subsequent ignition. For the remaining flight tests using this version's Super Heavy booster, the angle of attack for booster descent will be lowered to decrease aerodynamic forces and minimize the likelihood of structural failure. So this is interesting also. SpaceX works with an experienced global response provider to retrieve any debris in its wash-up in South Texas or Mexico as a result of Starship flight test operations. During the survey of the expected debris field from the booster, there was no evidence of any floated or deceased marine life, so that's good. So no, major environmental impacts, obviously, the emissions from the rocket and stuff like that. And then there's also there's been talk about issues with the sound from it and stuff like that. But there's no evidence of any floating or deceased marine life that would signal booster debris impact harmed animals in the vicinity. Following a successful stage separation, the Starship's upper stage lit all 6 of its Raptor engines and flew along its expected trajectory. Approximately 3 minutes into the burn, the sensors in the nose cone detected a steady increase in methane levels, which is not a good thing. So this continued until approximately 5 minutes into the burn when pressure began to rapidly decrease in the main fuel tank, while pressure simultaneously increased in the nose cone. Starship systems were able to compensate for the drop in the main tank pressure and completed the ascent burn, achieving the planned velocity and second stage engine cutoff, or SECA. After the engine shut down, the elevated nose cone pressure combined with the planned nose cone venting led to a large amount of attitude error, which continued to build up until the vehicle's automatic fault system disabled nose cone venting. The attitude error resulted in the ship automatically skipping the payload deploy objective, which was also unable to be completed as the higher nose cone pressure resulted in adverse loads on the mechanism responsible for opening the payload door. So that's why they had trouble with opening that door. So the vehicle was able to gradually decrease attitude error using reaction control thrusters until nose cone venting was re-enabled as planned. Roughly 40 seconds after nose cone vents were re-enabled, onboard cameras showed liquid methane entering the nose cone and temperatures in multiple sensors controllers started dropping. This eventually triggered automatic activation commands into the vehicle, which resulted in Starship skipping the in-space burn, so that's what I took you at, and venting all the remaining propellant into space. Starship then re-entered Earth's atmosphere in an off-nominal attitude, and communication was lost during re-entry. So lots of cool details. Obviously, you saw all this happen as you saw the launch in person or watched the webcast, but it's really neat to get all the details about technically what happened. So final telemetry showed from Starship was received approximately 46 minutes into the flight test, while the vehicle was approximately 59 kilometers in altitude and inside the designated entry area over the Indian Ocean. So there were no autonomous flight safety system mission rule violations or initiation of the flight termination system. SpaceX led the investigation efforts with oversight from the FAA and participation from NASA, the National Transportation and Safety Board, and the United States Space Force. The most probable root cause for loss of the Starship upper stage was traced to a failure on the main fuel tank pressurization system diffuser. Cameras inside the vehicle showed a visible failure on the fuel diffuser canister, which is located inside the nose cone volume on the forward dome of the main fuel tank. So while pre-flight analysis did not show a predicted failure, SpaceX engineers were able to recreate the failure using flight conditions and testing at the facility in McGregor, Texas. So to address the issue on upcoming flights, the fuel diffuser has been redesigned to better direct pressurized gas into the main fuel tank, and substantially decrease the strain on the diffuser structure. The new design underwent a more rigorous qualification campaign, subjecting it to flight-like stresses and running for more than 10 times expected service life with no damage. And so let's get back to talking about Ship 36. On Wednesday, June 18th tonight, you may have seen the video. So at 11 p.m. Central Time, Ship 36 preparing for its 10th flight test experienced an anomaly while on the test stand that was quite explosive. So the vehicle was in the process of loading cryogenic propellant to its engine static fire when a sudden energetic event resulted in the complete loss of Starship and damage to the immediate area surrounding space. So, as is the case before any test or launch, a safety zone was maintained around the test site and all hazards remained within the safety zone. There were no reported injuries or safety violations. The most probable root cause was identified as undetectable or understream damage to a composite overwrapped pressure vessel, or COPV, in Starship's payload bay section, which failed and resulted in a structural failure of the vehicle, causing subsequent propellant mixing and ignition. The COPVs in the payload section store gaseous nitrogen for use in the Starship environmental control system. So to address this issue, COPVs on upcoming flights will operate at a reduced pressure with additional inspections and proof tests added before loading reactive propellant onto a vehicle. SpaceX has also updated its COPV guidance acceptance criteria and developed a new non-destructive evaluation method to detect internal COPV damage. New external covers are also being added to COPVs during their integration, adding an additional layer of protection and visual indication of potential damage. So I really love just how open SpaceX is about all this. It's really good that I'm telling us when the next test will be, so for coverage purposes, it's helpful for learning about this. So that's just an overview of everything that happened with that. So that's really interesting. So definitely make sure to subscribe for further updates on all of this. So thank you for watching, and I will see you in the next video or live stream.